Electric generator. So electric generator is a device. If you see here, it's a generator means generating, electric means electric generating a device. So it's a device used to convert mechanical energy into electrical energy. So this consists of, again, insulated copper wire. This is the insulated copper wire. Then we have magnetic poles. These are magnetic poles. Split rings. These are split rings. And axle. This is axle. Brushes. These are brushes, right? And galvanometer for electricity, knowing the electricity, how much it is produced. So an axle here is rotated so that it moves clockwise direction. That is, this AB moves up and this CD moves down like this. It moves up and it moves down. After half a rotation, the CD starts to move up and AB down. So now it moves like this. So after every half rotation, current changes its direction, and this is called the change in the direction, and there is a generation of current, which is the current which is produced here. That is how mechanical energy of this, because of axle, is converted into the electric energy. So in electricity generation, a generator is a device that converts the mechanical energy into electric power for use in some external circuit like this. The sources of mechanical energy includes the steam turbines, gas turbines, water turbines, internal combustion engine, and even hand cranks also. So the first electromagnetic generator, the Faraday disc, was invented in 1831 by British scientist Michael Faraday. And generators provide nearly all of the power of electric power grids now. So the reverse conversion of this electric energy, as I just explained you, into mechanical energy is done by electric motor. You can say it's a counterpart of electric generator, electric motor. And motors and generators have many similarities. Many motors can be mechanically driven to generate electricity, and they are frequently make acceptable manual generators.